Welcome to Tech Girl Kannada YouTube channel.
East Len.
Function. Syntax. Description. Example. 1. Stlen. Size underscore t stlen, const char asterisk s. Returns the length of the string pointed to by s, excluding the null terminator \0. Char str equals data.
Copy. Including the null terminator \0. Char str equals data. Int len equals strlen str. Len is 4. 2. strcpy. Char asterisk strcpy, char asterisk dest, const char asterisk src. Copies the string pointed to by src, source, to the array pointed to by dest, destination. Char dest, 10. Char src equals copy. strcpy, dest, src. Dest is copy. 3. Strcat. Char asterisk strcat, char asterisk dest, const char asterisk src. Concatenates, joins, the string pointed to by src to the end of the string pointed to by dest. Char s1, 20, equals hello. Char s2, equals world. Strcat, s1, s2. s1 is hello world. 4. strcmp. Int strcmp, const char asterisk s1, const char asterisk s2. Compares two strings lexicographically. Returns 0 if they are identical, a negative value if s1 s2, and a positive value if s1 s2. Int res equals strcmp, apple, ball. Residential is 0. 5. str. Char asterisk str, const char asterisk haystack, const char asterisk needle. Searches for the first occurrence of the string needle within the string haystack. Returns a pointer to the first character of the found substring, or null if not found. Char t equals abcd. Char p equals bc. Char asterisk found equals str t p. Found points to b. Next steps. I have completed the answers for questions 4, 5, and 6 from Module 1. The next critical section in Module 1 involves the Knuth-Morris-Pratt, KMP, pattern matching algorithm, questions 7 and 8. Would you like me to generate the answers for KMP algorithm, Q7 and Q8, now, or would you prefer to move to a different module or section? Certainly. We'll continue with the advanced pattern matching questions from Module 1. I will now provide the detailed answer for the Knuth-Morris-Pratt, KMP, pattern matching algorithm, which is crucial for efficient string searching. Module 1, Introduction to Data Structures, Kant. Question 7, Define pattern matching. Write the Knuth-Morris-Pratt pattern matching algorithm and apply the same to search the pattern ABCD in the text ABCD. Answer. Definition of pattern matching is the process of finding all occurrences of a shorter string, called the pattern, \text, p, within a longer string, called the text, \text, t. The goal is to identify the starting indexes in the text where the pattern exists as a substring. The Knuth-Morris-Pratt, KMP, algorithm. The KMP algorithm is an efficient string searching method that avoids re-examining characters of the text that have already been matched. It achieves this by pre-processing the pattern to create a special array called the prefix function, or LPS array, longest proper prefix, which is also a suffix. This array tells the algorithm exactly where to restart the match after a mismatch occurs. KMP algorithm, search phase. Pre-processing, compute the prefix function, \pi array, for the pattern \text, p. This array stores, for each index j, the length of the longest proper prefix of \text, p, 1 \j, that is also a suffix of \text, p, 1 \j. Initialization, initialize two pointers /indices \text, I equals 0, for the text \text, t, and \text, j equals 0, for the pattern \text, p. Matching, while \text, I, is less than the length of \text, t. Case 1, match of \text, t, I equals \text, p, j, increment both \text, I, and \text, j. Case 2, full match of j equals the length of \text, p, a match is found at position \text, I, j reset j using the prefix function, j equals \pi, j1. Case 3, mismatch of \text, t, I, \text, p, j. If j greater than 0, reset j using the prefix function, j equals \pi, j1. If j equals 0, the first character of the pattern did not match. Increment \text, I. Application example. Text, TABC XABC DAB XABC DABCY, length equals 19. Pattern, PABCDABCY, length equals 8. Step 1, compute prefix function, pi array, 4p index, j, 0, 1, 2, 3, 4, 5, 6, 7 chart, ABCDABCY, pi 0, 0, 0, 0, 1, 2, 3, 0. Step 2, trace the KMP search of text, t index, text, j, p index, p, j, comparison action pi, j1, 0, 0 at a match text, j++, 1 to be a 1 be a match text, j++, 2c match text, j++, 3x 3 d a mismatch j equals pi, 2 equals 0, I stays. 0 3x 0 a mismatch j is 0. Text, For a 0 at a match text, j++, 5 to be a 1 be a match text, j++, 6 to see a 2 see a match text, j++, 7 to d 3 d a match text, j++, 8 a 4 at a match text, j++, 9 to be a 5 be a match text, j++, 10 text 6 see a mismatch j equals pi, 5 equals 2. Text, I stays. 2 10 x 2 c mismatch j equals pi, 1 equals 0. Text, I stays. 0 10 x 0 a mismatch j is 0. Text, I++. 11 a 0 a match text, j++, 12 be a 1 be a match text, j++, 13 c 2 c match text, j++, 14 d 3 d a match text, j++, 15 a 4 a match text, j++, 16 to be a 5 be a match text, j++, 17 c a 6 c match text, j++, 18 y 7 y match text, j++, 19 8 match found. Text, I, j equals 19 8 is equal to 11, j equals pi, 7 equals 0. 0 for result, the pattern ABCDABCY is found in the text starting at index 11. Next steps I have completed the detailed answer for the KMP algorithm, question 7. The remaining unanswered questions in Module 1 primarily cover dynamic memory allocation, Q10, Q11. Array representation and operations, Q12, Q16. Structures and unions, Q17, Q24. Sparse matrices, Q26, Q28. Polynomials, Q29, Q30. Which of these topics would you like me to focus on next? For example, dynamic memory allocation and arrays? Understood. We will proceed to answer the remaining questions in Module 1 sequentially, starting with dynamic memory allocation and arrays. Module 1, Introduction to Data Structures, Kant, Question 10, differentiate between static and dynamic memory allocation. With this knowledge, explain the different dynamic memory allocation functions with the proper syntax and examples. Answer. Static versus dynamic memory allocation, DMA, feature static memory allocation, dynamic memory allocation, DMA, allocation time, done during compile time. Done during runtime. Lifetime memory is allocated for the entire execution.
Dynamic memory allocation. Memory can be allocated for variables using two techniques. Static allocation uses declaration and definition. Dynamic allocation using predefined function. Static memory allocation. If memory space is allocated for various variables during compilation time itself, the allocated memory space cannot be expanded to accommodate more data or cannot be reduced to accommodate less data. Once the size of the memory space is allocated is fixed, it cannot be altered during execution time. This method of allocating the memory during compilation time is called static memory allocation. Dynamic memory allocation. This is the process of allocating memory during the execution time or runtime. Memory management function used for allocating and freeing memory use during program execution are malloc, calloc, realloc, and free. Malloc allocates a request size of bytes and returns a pointer. Malloc allocates a request size of bytes and returns the pointer to the first byte of the allocated space. Calloc. Allocation space of the array of elements, initialize them to 0 and then return a pointer to the memory. Realloc modifies the size of previously allocated space when the requested memory is not available at the pointer null is returned. Free. Previously allocated space deallocates an area of memory previously allocated by malloc. Malloc. This function allows program to allocate memory explicitly as and when required and the exact amount needed during execution. Allocates a block of memory. Size of the block is the number of bytes specified in the parameter. Include stdlib.h. ptr is equal to data type star malloc n into size of data type. Data type star malloc n into size of data type. Typecast expression. Transform the resulting pointer into a pointer to the correct type. The pointer then assigned to the proper pointer variable. PTR is a pointer variable of type data type. Calloc, contiguous allocation of multiple blocks. Memory blocks having consecutive addresses, each of same size, then initializes the allocated memory to 0. All allocated bits and are set to 0. A pointer to the start of the allocated memory is returned. In case there is insufficient memory to make the allocation, the return value is null. PTR is equal to cast type star calloc n, element size. For malloc, it is PTR is equal to data type star malloc n into size of data type. For calloc, it is PTR is equal to cast type star calloc n, element size. N is number of blocks to be allocated, element size number of bytes in each block. Realloc, change the memory size previously allocated with the help of the realloc function. When realloc is able to do the resizing, it returns a pointer to the start of the new block. When it is unable to resize, the old block is unchanged and the function returns the value null. New memory block may or may not begin at the same place as the old one. PTR is equal to realloc PTR, new size. Realloc PTR, new size. Reallocating the memory will not destroy the original contents of memory. Free. No longer need an area of memory, free it by calling another function free and return the area of memory to the system. Free PTR. After freeing the memory, the pointer value stored in the PTR is not changed. It still contains the address of the first byte of the memory block allocated earlier. Using the pointer PTR even after memory has been released is a logical error. These logical errors are difficult to debug and correct. So immediately after freeing the memory, it is better to initializing to null value. Allocation and deallocation of memory. Int I star p float f1 star pf. Pi is equals to int star malloc size of int pf float star malloc size of float. Star pi is equals to 1024, star pf is equals to 3.14. Free pi, if we insert the line pf float star malloc size of float free pi immediately after the printf statement, then the pointer to the storage, use it to hold the value 3.14 has disappeared. Now there is no way to retrieve the storage. This is an example of a dangling reference. Structures. Arrays can be used to represent a group of data items that belong to same type. But structure is a mechanism of the packing data of different type. Structure is a mechanism of packaging a data of format, then declare structure variable. Struct tagline. Data type member 1, data type member 2. The structure definition has not declared any variables. It describes a format called template to represent information. During definition, no space is reserved. Once it declared, memory space is reserved. Declaration, tag structures, structure variables, type defined structure. Structure is for handling a group of logically related data items and can be accessed using variables, array derived data type, structure programmer defined. Tag structure, struct tag name. Structure definition with tag name, name of the structure, tag name. Struct tag name A1, A2, A3. Variables of type struct tag name. Members of structure themselves are not variables. It won't occupy any memory until they are associated with the structure variables. Size of the memory allocated is the sum of the size of individual members. Structure variable struct A1, A2. Not recommended without tag name. Can't use it for future declaration. Type defined structure. Type def struct type member 1, type member 2, type name. Name of the type defined by the structure definition follow this. The declaration of variables. Type def is a keyword that allows the programmer to create a new data type name for an existing data type. Create meaningful data type names for increasing the readability of the program. Type def struct student student. Structure defined definitions appears at the beginning of the PGM file before any variables or references are defined. Also appear before the main along with macro definitions such as hash define. In this case, definition is global and can be used by other functions as well. Accessing structure members. Members themselves are not variables. It should be linked to the structure variable in order to make it meaningful member. Link between a member and a variable established using the member operator called DSA operator or a period operator to select the particular member of the structure. A1.member1 A1 member1 is equals to 100, A1.member2 is equal to 200. We scanf to give the values through the keyword. Structure initialization. Main struct and double in text student is equal to this, and student is a variable which has two fields. Algorithm to add two polynomials using ADT polynomials. If lead exp of A equal to lead exp of B, sum is equal to coef of A dot lead exp of A plus coef of B dot lead exp of B. If sum not equal to 0, attach C comma sum comma lead exp of A. A is equals to remove of A comma lead exp of A. B is equals to remove of B comma lead exp of B. If lead exp of A greater than lead exp of B, attach C comma coef of A comma lead exp of A comma lead exp of A. A is equals to remove of A comma lead exp of A. If lead exp of B is greater than lead exp of A, attach C comma coef of B comma lead exp of B comma lead exp of B. B is equals to remove B comma lead exp of B. If one of the polynomial becomes empty, copy remaining terms from other polynomial into C. Polynomial representation. Polynomials can be represented using single dimensional arrays in C using two methods: using a structure consisting of an array or using an array of structures. First method, using structure consisting of an array. We have a type def to create the type polynomial. Define max deg 101. Max dot degree is polynomial plus 1 for degree of polynomial. Struct polynomial int degree. Float coef of max deg 101. Type def struct polynomial A comma B. Type def struct int degree float coef of max deg polynomial A comma B. Degree coef 25x bar 4 plus 12x square plus 2x plus 7. Degree of polynomial can be accessed using A dot degree. Coefficient can be accessed using A dot coef of 3. Advance if the same terms with 0 coefficient are present, this representation uses less space. Disadvantage: if most of the terms are not present, then we store zeros in the corresponding coefficient and occupy more spaces to overcome by array of structures. Second method, instead of using one array for each polynomial, use one array to store all the polynomials used to same space. E of x is equal to 2x bar 100 plus 5. P of x is equal to x bar 4 plus 10x cube plus 3x square plus 1. Each location consists of two fields: coef and exponential. Coef start A and A, start B and B. Poly A, poly B. Yeah, I have two things here. And a representation of two polynomials. The index of first term of A and B is given by start A and start B, while end A and end B given the index of last term of A and B. The index of the next free location in the array is given by a while. Define max term 100. Type def struct float coef int expo polynomial p of max term. Both polynomials a and b are represented using only one array. Advantage: if more number of zero terms are present, this representation uses less space. If more number of non-zero coefficients are present, this representation occupies twice the memory occupied by previous method. Polynomial addition: void poly or add polynomial in pointer p, int start a, int end a, int start b, int end b, int start c, int star end c. Start c is equal to a while start a less than or equal to end a and start b less than or equal to end b. Switch. Compare p of start a dot expo, comma p of start b dot exp. Okay, just a starting number we should compare, and then if they are not same, start a plus plus, start b plus plus, break. Case 1, attach p of start a dot coef, comma p of start a dot expo dot p. Start a plus plus, attach of b, comma p. Start a plus plus, break. Default attach p of start b dot coef, comma p of start b dot expo, comma p. Start b plus plus, default. While start a is less than or equal to end a, attach p of start a dot coef dot p of start a dot expo p. P of start a dot coef, comma p of start a dot expo, comma p. Start a plus plus. While start b is less than or equal to start end b, attach p of start b dot coef, comma p of start b dot expo p, start plus plus, and end c is equal to a while minus 1. What is sparse matrix? A matrix with m rows and n columns. The total number of elements in a matrix is mn. If m equals to n, the matrix is square. Matrices with a relatively high proportion of zero entries are called sparse matrix. Sparse matrix can be single dimensional or multi-dimensional. Value can be stored as a r comma c or in c equal to value. Any element in a matrix A can be accessed using triples or comma c comma value. ADT sparse matrix. Objects: a set of triples RC value where row column are integers and form a unique combination value comes in the form of the set item. Function: for all a b belongs to sparse matrix, ij mod r max c belongs to index, x belongs to item. Sparse matrix: create max c in max c, max r and max c. Sparse matrix transpose of A: return the matrix produced by interchanging the rows and column values of given triple. Dimension of two matrices are same. Return the sum, else return 0. Sparse matrix multiply AB. A is equals to m into n, B is equals to P into Q. If n and P are the same, multiplication possible, return matrix C, else return 0. Sparse matrix representation. Use an array of triples to represent a sparse matrix. Define max term 101. Type def struct int r int c int value term. Term A of max term. Term A of max term. Max number of terms plus 1 rows, number of columns, number of values are there. Now here they have given the matrix. A of 0, fifth row column and value 8, 0, 0, 10, 0, 3, 40, and all they are all given. Size of the matrix accessed using A of 0 dot row, A of 0 dot column. Number of non-zero elements, A of 0 dot value. Row index of a non-zero element, comma, a of j dot row. Column index of a non-zero element, a of j dot column. J is equals to 1 to a of 0 dot column. Index of a non-zero element, a of 0, a of j value. Okay. Transpose of a matrix. A matrix which is obtained by interchanging a row and element into a column element and column element into a row element. Just making them into a b of 0, b of 1 matters. Y transpose of term A, term B int I j k, b of 0 dot row is equal to a of 0 dot column, b of 0 dot col is equal to a of 0 dot row, b of 0 dot val is equal to a of 0 dot val, k is equals to 1. For I is equals to 0 is less than a of 0 dot column I plus plus where j is equals to 1 and j is less than a of 0 dot val j plus plus. If a of j dot col equal to I, if a of j dot col equal to I, b of k is equals to 1. Listen. B of k dot row is equals to a of j dot col. B of k dot col is equals to a of j dot row. B of k dot val is equal to a of j dot val. K plus plus. Position of first non-zero element. The string abstract data type, whose components elements are characters. As an EDT, we define a string to have the form s is equals to so and so, where si are characters taken from the character set of the programming language. If n is equals to 0, then s is an empty or null string. There are several useful operations we could specify for strings. Structure string as objects. A finite set of 0 or more characters. Functions. For all st string ijm non-negative integer, string null of m, return string whose maximum length of m characters but initially set to null. Integer compare st, return 0 if it's equal, return 1 if it's not. Boolean is null, return false. Integer length, the string concat of s, t, string subster of sij, anything is there. Then pattern matching. Assume that we have two strings, string and pat, where pat is a pattern to be searched for in string. The easiest way to determine if pat is in string is to built-in function str. If
Thank you for watching. Do like, share and subscribe to my channel.